right? So let's, before we go into the concrete mix design, let's have a general introduction about the concrete. So, introduction of concrete. And again, we mentioned this before, that every time we talk about concrete is actually we're talking about Portland cement concrete. But since in the construction industry, most of the time when we talk about, when we refer to concrete, we mean the Portland cement concrete, right? There is other types of concrete like asphalt concrete that we use it for pavement applications. But again, in the construction, most of the time we refer to Portland cement concrete as concrete. And you as engineers will be responsible, so engineers will be responsible for the design of the mix of the concrete. So you need to know, or you need to tell the concrete plant how much coarse aggregate, how much sand, how much water, and how much cement, and what type of mixtures they need to add to the concrete mix design to have the exact, or the range of the strengths that you're looking for, and also the type of properties in terms of setting, workability, and other types of concrete properties that you need for a specific application. For example, if you're mixing concrete for a building, or a dam, or a concrete pavement. The engineers are responsible for the design of the mix. That's the first part. And also they are responsible for the final quality of the concrete. Right? That means that you need to do a quality control, and also a quality assurance. We call it the QC QA process. So QC QA process, that's the quality control, quality assurance, that you need to control the process while you're building and pouring the concrete and building the materials. And also you need to, after the construction, you need to make sure the quality assurance process, to make sure that the final quality of the final product is according to the standards. And we talked about the concrete ingredients. So ingredients. We talked about this before, that the major ingredients of the concrete are basically aggregates, which is fine and coarse aggregates. And then we have Portland cement, or PC. And then we have water and chemical admixtures. Right? And then we also, just a quick flashback, we also talked about different types of combination of water, aggregates, and cement. We had paste, which is Portland cement plus water. And we also have mortar, which is Portland cement plus water plus fine aggregates, right? And then we have concrete, which is everything plus water plus fine and plus coarse aggregates. Right? Yes, thanks for the correction. This is April 8th. Okay. All right. So those are the major ingredients or components of the concrete. Now, we also need to know that the quality of the concrete. So quality of concrete. It's depending on depends on chemical composition, it also depending on the mixing process. How do you mix the ingredients together? How do you transport the ready mixed concrete? The hydration process, the placement of the concrete, how do you place and how do you pour the mixed concrete, how do you vibration process to make sure that the concrete is covering all the spaces between rebars. You need to cure the concrete to after placing to make sure that the hydration process is complete and you're reaching the maximum strength that you're looking for, that you're designed for. It also depends on the proportions. We talked about this a little bit before, that if you add too much water to the concrete, the water to cement ratio is too high, then your strength is low. And for higher strength, you need to lower the water to cement ratio. It also depends on the type of water. We talked about what type of water and what level of contamination you can use in the concrete, and also it definitely depends on the type of aggregate and the properties of the aggregate that you are using in the concrete. Okay, so what are the order of operations for concrete? So order of operations for concrete. Oh, it does? Is it better now? Okay, sorry for the echo of the speaker. I had the speaker on the other computer. Okay, so the order of operations for concrete is that you first design the mix proportioning. So mix one is mix design, or the which is the proportioning. Right? And then the second step is the trial mixes. You need to mix different proportions in the lab, and test them for the concrete durability and strengths to make sure which mix is the best one. And then you need to batch So batching is basically getting aggregates from stockpiles and mixing them together with different ingredients. And from here, you start a clock. So start the clock. And what that means is that from here, the timing is very important because from the time you mix the ingredients together, the hydration process starts, and then you need to control what time or how much time after the mixing process you're placing and transporting and curing the concrete. So you mix after this, then you transport the concrete, and then we have placing of the concrete at the project site or at the construction site, and then you have the consolidation process, which again you need the vibration to make sure that the concrete is covering all the spaces between the rebars. And then at this point you have the initial set time. Initial set time. That means that the concrete starts to set here, and then you have the finishing, the surface finishing. If you have, if you need to finish the surfaces, this is the time to do it. And then you have the final set time here. It means that at this time the concrete starts to harden, and you cannot change the surface anymore. So at this point, the curing process starts. And then during the curing, you need to make sure that the curing process is taking place properly. And then you also need to have the maintenance process. All right. So these are basically this is the timeline of the concrete mixing process. Okay, let me go back probably over here. And then again, the most important thing about the concrete is to design the proportions. So proportioning of concrete mixes. Or most of the time we call this briefly as mixed design. So whenever we talk about mixed design, we are basically determining the proportions of the concrete mix. So the goal of the mixed design is to determine the proportions of mixed ingredients that will be, we want to, what the goal of the mixed design is to be economical. It means that you don't want to have too much cement in the mix just because it increases the strength or it improves the properties, because that's not going to be economical, and it's going to be too expensive. You also want to be practical. Means that you cannot just say we need this type of aggregate if you don't have that type of aggregate available in the area. And so you need to use available materials. And you also need to meet specifications. And standards. There are a lot of ASTM standard processes for mixing the concrete, placing the concrete, curing the concrete, the hydration process, and all the tests that you need to do for the fresh concrete, and to determine the properties of the fresh concrete and also the properties of the hardened concrete. So in terms of properties, there need to be an acceptable level of acceptable workability of fresh mix. Then you need to have quality, which is durability, strength, and appearance. This is the quality of hardened concrete. So you need to monitor both the fresh properties and also the hardened properties. And also we need to make sure that, again, it's economical, right? Now, what method we can use for the mix design? So mix design methods. There's a traditional method that people use it for when they don't have access to a mixed design, to a professional mixed design system, or to an engineer to mix the concrete or to provide the mixed design proportioning. And it's called the arbitrary volume method. So the arbitrary volume method that you've probably heard of this before, that it's called 1, 2, 3 method. So 1 through 3 method means you have one portion of Portland cement, or 1 unit of Portland cement, 2 units of sand. So it's if it's, I don't know, if it's bucket, it's going to be 1 bucket of Portland cement, 2 buckets of Portland sand, 2 buckets of sand, and then 3 units of coarse aggregates. Right. Again, this is not the engineering method to mix the concrete, and it's just very basically just to mix ingredients together and have a typical concrete mix. There is also another type of the mix design that you design by weight. So weight method. You also have the absolute volume method. And this method is actually the most accurate one. And also, most of the time that we are doing the mix design, we are designing with, or we're designing by volume, right? So this will be the most usual type of design method. So this is the last thing that I'm going to cover today. The mix, in the volumetric mix design. So in the volumetric mix design, the steps. These are the steps that you do need to follow for the volumetric mix design. The first step is to determine what type of strengths or what level of strengths you're looking for. So strengths requirements. Second one is you need to determine what is your water to cement ratio. Determine water to cement ratio. Third step is to estimate the coarse aggregate mass. So estimate coarse aggregate mass, the weight of the coarse aggregate. The next step is what type of air or what level of air voids you need to have. So air entrainment requirement. For example, if you're building a concrete pavement, you have there's a different level of air void requirement compared to a slab or structural component. The workability needs. Workability is basically how workable or how fluid the fresh concrete is. So you need to know that. Then the next one is what is the water content based on, you have the water to cement ratio, and you can basically calculate how much water you need. So estimate the water content. Then based on knowing the water content and knowing the water to cement ratio, then you can determine Portland cement content. That's how much Portland cement you need to have in the mix. You also need to evaluate what type of admixtures you need to have in the mix. So evaluate admixture requirement. Requirements. Then you need to estimate how much fine aggregates you need, or fine aggregate mass. And then the one before the last step is determine the moisture correction, if you need to correct your moisture content. Because your aggregate might have already moisture content in it, so you need to estimate that how much more or how much less water you need to add. And then the last one is to make a trial mix and see how that works. And if it works fine, then we can go for the batching process and mass production in the plants. Okay, so I'm gonna stop recording now.